started.
Welcome back, students. Today we will begin our new unit on motion versus time graphs and velocity versus time graphs. We will be discussing the difference between scalar and vector, seeing how the slope of a graph relates to velocity, seeing how the slope of a velocity versus time graph relates to acceleration, learning how to graph motion versus time and velocity versus time graphs, and learning how to use the area of a velocity versus time graph to calculate displacement. So, wait, give me one piece of paper. So what do you know about scalar and vector?
I know a vector is a length and a direction. I don't know what scalar is.
So what do you know about velocity and acceleration?
Velocity is the speed in a direction, and acceleration is change in velocity.
So what's the difference between velocity and speed?
Speed is just how fast you're going. Velocity is how fast you're going in what direction.
So, okay. Scalar means it can only be in one direction. Vector means it can be in multiple directions. Like speed can only be positive. Velocity can be both positive and negative.
Oh, I didn't know that.
So this is a velocity versus. This is a position time graph.
Sit down. Okay. Which side does time go on?
Time goes on the bottom, and
Okay.
displacement in meters goes on the left side. If the slope of a position time graph is positive, that means that the object is moving away from the origin. If the slope is negative, it means it's moving towards the origin. And if the slope is horizontal, that means the object isn't moving at all.
Okay.
So if on a motion time graph, if the slope curves, that means that the velocity is changing.
Okay.
If it's just a straight diagonal line, that means that the velocity is constant. Okay, now then this is a velocity versus time graph. Notice how unlike the motion versus time graph, not all of the lines are connected. That's because when the velocity changes suddenly, there's no connection between the lines. You just draw them like, say,
Give me an example. I don't.
if you go from a velocity of 5 meters per second to a velocity of 2 meters per second, the object never hits 4 or 3 meters per second. So you just draw it as 5 meters per second and then just 2 meters per second.
Okay.
If the line is horizontal, that means that the velocity is constant.
Mm-hmm.
If it's diagonal, that means the velocity is increasing at a constant pace or a constant acceleration.
Okay.
Acceleration means the change in velocity. Now, when you're using a velocity time graph, you can actually use it to calculate how much an object has been displaced. For example, you take a line segment, and then you multiply the velocity versus the time to get the area. Now, if there's a diagonal, you have to use the right triangle formula.
Right. I
One
know that
half
one.
base times height to
Okay.
get the area.
Okay.
Now, the area of that segment of line is the total displacement in meters.
Should you say that again?
So, the amount of so when you take a velocity time graph,
Mm-hmm.
say this is the origin. Now the segment goes like this. Now in order to find the area of this segment right here, you find the area of it.
So basically, it'd be half, because if that's 1, if you make the unit 1, and that's 1, each line on the, then that would be 1 and 1, it would be 1 half. Be 1 times 1 times half, so it'd be half.
Yes. And then so you take the line segment
Uh-huh.
and then just calculate the area between it and the horizontal line through the origin.
Okay.
Now, so in this problem, how far does this line, how far does the object move during this line segment?
Well, this is seconds, and this is
Yes.
meters,
Yes.
so 0. It stays it's flat.
No, this is a velocity time graph.
Oh, meters.
So what you do is, since this is the origin, you draw lines like this. Yes, to visualize
2.
it.
So it'd be 6. No, it'd be 4. 2 and 2.
No, this is a 20.
Oh,
So
20.
for this line segment,
Yeah.
this is 1 to 3 seconds. That's 2 seconds, and
Yeah.
it's moving at 20 meters per second. That means that
Oh, so it went 40 meters.
correct.
Okay.
Now, what if now say what if it moves like this? What is the total displacement during that time?
If you go back to your equation you gave me, 1/2 base times height. The height is -3. The time, the base is 3, so it's -9. 1/2 of that, so it's not -9 over 2. Is that right?
Correct, but remember, when you write out the answer, you need to write in the unit.
Okay, those meaningless meters. So it's 4.5 meters because the seconds,
Correct.
meters per second, seconds a second. Okay.
Now, this is a motion time graph. How does the object move during this time? Describe it.
Motion. So this is meters
Correct.
of displacement, and this is second. It's stationary.
No, from the start to here.
Okay. It is moving at a constant velocity, and then the velocity is 0, and then it decelerates, but at a changing velocity.
Yes. It moves at a constant positive.
Right, constant positive velocity.
Then this
And then-
is no velocity, and then this
Decelerates, but
Yes, this decelerates at a constant pace.
okay.
So now it's time for the quiz.
Okay. So it's moving at a constant. Didn't read the question. Is that right?
Okay. Now, first of all,
Oh, I forgot to do the last question. How to create the displacement times 0 to 15, it displaces 6. 0, 6.
okay.
Read all the questions. Like,
Okay, now time to grade the quiz.
stationary in my handwriting. It's a 90. That's wrong though, my velocity's too high, I got 0. Should have done the area, so it's 15. What was the answer to this one?
You got 75%. The answer to this one would have been it should have looked like this.
Oh, you do each segment. You didn't do the whole thing.
So it's going to be for 5, and then 0 for 2, and then that's going to be like this.
Okay.
This is the correct answer.
Okay. Let's do the next one.
Stop it.
You don't have to teach both.